Okay, now I'm going to start the presentation. Okay, if it is not visible, please do tell me. Fine.
Okay, sir.
Yeah, sure. So you can hear me, right?
Yes, sir.
Yes, sir.
Yeah.
Yes.
So we are going to start the new semester. This year, fifth semester, and this subject is actually theory of structures 5. Theory of structures 5. That is the design of steel and timber structures. Design of steel and timber structures. Okay. So this will be handled by myself, Asif Bashir from Department of Civil Engineering, and Professor Bushra M.A. She's also my colleague. She's also from Department of Civil Engineering. Okay. So if you got any doubt, you can ask me in between. We'll provide you our numbers, phone numbers, so that if you have any doubt, you can ask in between. Okay, fine. So the course objectives is to introduce the limit state design of steel structure. You have studied what is limit state, right? We have studied before what is the meaning of limit state. We have studied this in the case of concrete structures. Do you remember that? Concrete structures, we have studied what is limit state. IS 456 2000, we had done the limit state design of steel structures, isn't it? Sorry, concrete structures, isn't it? So here we are starting the design of steel structures. The same limit state design we are doing here for designing the structure in bending, compression, and tensile loads to take the bending stress, compressive stress, and tensile load coming on the structure, as well as we are designing the timber structure. For designing the timber structure, we will be designing mainly for flexure only. Flexure only. That is, we will design only the timber beam, and a single problem from column or something will be there. Okay. So in your syllabus, TOS 5 consists of mainly two. That is, at the beginning I told you this design of design of steel structures, as well as design of timber structures. Your four modules will be design of steel structures, and two modules will be design of timber structures. So that constitute your TOS 5, that is theory of structures 5. A brief syllabus introduction to the syllabus is design of steel structures. I told you have four modules: module 1, 2, 3, and 4. Your module 1, 2, 3, and 4. We have the modules 1, 2, 3, and 4. In that, the first module is the introduction to steel structure. Whatever things we are going to study, what is the need of this design of steel structure, what is the relevance or what is the use of studying this subject. You will study in this introduction part, and the material properties, different material properties used in steel design, and a small numerical type, that is the design of connection, that is design of welded and bolted connection. Excuse me for 1 second. Okay, someone has asked to join, that's why. Someone has asked to join. This is a problem. Okay, if you are not using your TKMC ID, it's very difficult for me to, in between, I need to stop the class. So can you see the presentation now?
Yes, sir.
Yes. Are you able to follow this?
Yes.
Are you able to follow?
Yes, sir.
Yes. So the fourth module, first module is the
Yes, sir.
introduction part. Then you study the material properties. Then design of welded and bolted connection. How do you design the connection? What is the number of bolts required? what is the length of the weld required. All those things you will study in the bolted connection and welded connection design. Then comes the design of tension members. You haven't studied the design of tension members in your concrete technology, that means RCC, because the RCC is very, or the concrete is very poor in taking wash. Can someone tell? The concrete is very poor in taking wash.
Tensile force.
Tensile.
Tensile
It's
load.
very poor in taking tension. That's why you studied what? Reinforced cement concrete. That is in order to increase the tensile strength of concrete, you have introduced the reinforcement into the concrete such that the tensile or the drawback of the concrete will be taken care by the reinforcement. But here in steel is very much good in taking tension as well as what? Compression. It's very good in taking tension as well as compression. So you will study here the design of tension members. You will study the design of tension members. Then you will study the design of compression members, that is small compression members used in truss, that is a strut. The compression members used in truss. Then you will study the major compression member, that is the columns. You will study the design of beams and the design of slab bases, that is the foundation you will study. So you will study, you can either note this down or I'll give you the presentation. This is the brief of your syllabus. This much things you need to study in your first 4 modules, and you'll be having your first series on first week of October, and they will be having your first 2 modules. Okay, and that will be most probably that will be online, but the end semester examination will definitely be an offline examination. So you need to be a little bit serious about the subjects which you are going to study this semester. It's not like last semester. Okay, fine. Can I move to the next slide? Can I move to the next slide?
Yes, sir.
Yes, sir.
The design of timber structures, you have introduction similar to what you have seen in steel. You have the introduction to timber structures. Then you have design of timber beams. Then the last module and the final module has the design of flitched beam, that is composite section. It will be having both steel and timber. The section will be comprising of both steel and timber, and you have a small portion design of timber columns. This constitutes your theory of structures 5, and I hope it will be easy for you, and I hope you cooperate with me throughout this entire semester. Okay, now we'll move to the design of steel structures. We will start with the design of steel structures. So have you seen steel structures anywhere? Have you seen steel structures anywhere?
Yes.
Yes. Can you tell me someone? Where
In our own department.
Department. Which department you have seen steel structure? In your architecture department, right?
Yes, the renovated portion.
The new extended portion, right?
Yes, yes.
Yes, yes. Other place in the college, have you seen the steel structure?
In auditorium.
Very good. In auditorium, you have seen the steel structure. There you have used pre-engineered structures. They have made structures, they have made the section using plate. Actually, it's not hot roll, it is plate section. According to the need, we have casted the structure. Have you seen in railway station and all? There are many from Kannur, Kozhikode, Kochi. So you have traveled a lot in your trains, right? So we have seen the railway station, majority of the major construction are with steel structure inside the station, then inside the platform, or the platform, this overhead bridges, many things are made up of what? Steel only. Have you noticed that?
Yes, sir.
Many
Yes.
are traveling in train a lot of times, so you might have noticed. If you haven't noticed that, please do see whatever things we are studying in this design of steel structures you can see in the railway station, because major works in the railway department are being carried out with steel structure. I'll tell you why they are doing it in steel structure in the coming few slides. I'll tell you that. So if you haven't noticed that, please do notice. You can see major things: the connection, the tension member, compression member, everything you can see in the railway station when you are going. Just observe that. We can see what are things you are studying in this semester in the railway station. Okay, fine. So I'll move to the next slide. That is the different codes that you require for the design of steel structures. That is, last time we had your IS 456 2000. Here you are having your IS 800 2007. That is General Construction Steel Code of Practice. That is a steel code, IS 800-2007. Along with that, you require, I'll give you the PDF of this. You require a thing called a steel table. That is, the different type of section available in the market will be given by a steel table, or there is another given by IS code itself, SP 6, that is Special Publication 6, corresponding to IS 800-2007. You can, I'll give you the PDF of these three. This will be very much useful for you while we are doing the numericals and all. Okay, and major things regarding the design of the section will be provided by IS 800-2007, and for reference or taking the different section properties, you can refer the steel table. Okay, so the PDF soft copy of this I'll give you. I'll provide you in the Google Classroom as well as in your ET Labs. Either you can take the printout or you can have the soft copy with you, but any one of this should be readily available with you. I recommend you to take the hard copy, because you need to take this to your examination hall. Anyway, you need to take at some point of time. You're required to take the hard copy. Take it if possible now itself. It will be easy for you to study. And don't write anything with pen or pencil in your IS code. Okay, don't write anything. If you are writing anything, it will be treated as a malpractice in your examination hall. So don't write anything. You might have heard this last semester also, so I don't want to repeat it. Don't fold your IS code. Don't do such things. Okay, fine. And now next is, what are steel structures? So what do you mean by steel structure? Here, last time what we have studied was RCC. The load transfer takes place through what? The load which you are standing, suppose you are standing on a slab. The load from the slab will transfer to your beams. From there, it will transfer to your columns. From the columns, it will get transferred to your footing. From the footing, it will get transferred to your soil structure, or the base of your structure, isn't it? This is how the load transfer takes place, right? So there, it was all made of what? Steel. Sorry, it was all made of concrete. Now, what is this? We are replacing these things with steel. That is, the load transfer takes place through what? Steel elements or such structural steel. The load transfer takes place through structural steel, and the load bearing thing will be what? A steel structure. Then such structures are called as what? Then the structures are called as what? Steel structure. That is, in steel structure, a structural steel is the main load carrying material to transfer the load within them and to transfer the load to the ground. Last time we have studied RCC. There the load transfer took place through what? The load transfer took place through what? It took place entirely through what? Your RC members, that is a reinforced concrete member. Here, what you are going to see is the load transfer will be taking place through what? Steel sections. So can you tell me what is the difference between the steel section here and this reinforcing steel used there? Is it same? We have used the
No, sir. The other one is no. The other ones were just steel rods.
Yeah. So the difference is that are called as reinforcing bars or rebars, and here the elements or the things what we are dealing with are called as structural steel. See the word structural steel. It is called as structural steel. Okay. They itself will be taking the entire load. The other one is just reinforcing. That is adding strength to your member. It's only the part. It alone cannot take the whole load. It just adds the strength to your structure. It's just reinforcing your elements. Reinforcing means what? Just adding some extra property to your elements. That alone cannot take the load. But here, this element, that is a structural steel, alone can take or withstand the load, type of load which is coming on it. Either it is compressive, or it is flexural, or it is tensile. Whatever be, it alone can take the entire load. Okay. So don't get confused with reinforcing bar and structural steel. It's entirely different. The properties also are different. Okay. Have you seen the structural steel sections? I section. That is I section. You can see I section. This is the I section. That is based on the cross section. Based on the cross section of the elements there are different sections available in structural steel. Based on the cross section of the element, there are different sections available. That is I beam. You can see the I section, I beam. Then T section. See here the cross section. Here the cross section is in the form. Can you see this? The cross section is in the form of the T. Can you see this?
Yes, sir. Yes.
The cross section is in the form of a T section. So that section is called as a T section. Then there is channel section. See this here, the section is in the form of a C, right? The section, the cross section of the element is in the form of a C. That is called as a channel section. Then there are steel plates. Solid plates are there. The section is solid plates are there. It is simply like a steel plate which will carry. There will be solid plate there. Such sections are available. Okay, these are just few sections. There are different lot of sections in steel structure, and I will tell you what are the use of this I section, what are the use of this channel section, what are the use of this T section, etc. Okay. Now you might have seen this also. Like there will be a composite construction, that is steel and concrete will together will be used. At some places there will be a combination of both, that is the beam and column will be providing with steel, the beam and column will be providing with steel, and the slab will be provided with RC, that is concrete. The slab will be provided with concrete. You might have seen this. Have you seen this type of structures? That is the concrete column, and this will be given as the beam and column will be given as steel structure, and the slab will be given as concrete or RC. Have you seen this? Anyone? Is Mohammed Sain present?
Yes,
Sain.
sir.
Yes. Have you seen the same?
Yeah.
Yeah. If while you are traveling from this through National Highway, have you seen the Bismi Electricals many in Kochi and all? Have you seen that along the National Highway? Is
Yes,
major building of those Bismi Electricals are made of these things. That is, they are made of structural steel. I will tell you why they have done that. The advantages of steel, I will tell you why they have done that.
Okay,
So
sir.
there are structures which are having both steel and concrete, but our studies or our knowledge of this, our dealing in this semester will be entirely steel structure alone. There will not be steel concrete composite structure. Okay, just for information, I told you there are two types of structures. So three types of structures: steel, concrete alone, steel alone, concrete alone, as well as what? Steel and concrete composite structure. Okay. Now the common steel structures used. So this we have seen in factories. You have seen the steel structure. There will be a warehouse, different factories. We are using this steel structure in cinema halls. Why we are using steel structure in cinema halls? Can you tell me? Is Fatima there? Can you tell me that, Fatima? Why we are using this in cinema hall? Is Fatima there?
Yes, sir. Maybe for acoustic purpose.
Acoustic purpose. Okay, that's not exactly. So, have you ever? Okay, Padma, thank you. Okay, have you ever noticed the span of your cinema hall? It will be very large, right? You need to accommodate. The span will be pretty large, right?
Sir, column ഒഴിവാക്കാൻ വേണ്ടിയാണ്.
In between, if you are placing a column, what will happen? In between, if you are placing a column, there will be a view obstruction, right? The one sitting in the balcony or in between cannot see the screen perfectly, right? Isn't it? The same happens for auditorium also. They cannot watch the things what is happening on the stage. So in order to have a larger span, in order to take the larger span, we'll go for steel structures, because steel is having very much high strength than what? Concrete. Excuse me, can I ask you one thing? Is there any restriction from my side? Is there any distraction from my side? Students, please respond. Is
No,
there any?
sir.
Is there any
No, sir.
TV sound?
No, sir.
No, fine. Okay, fine. Then you can see in railways, etc. Same thing. Have you seen in crane girders? Have you seen crane girders? There is the structure supporting crane. The structure supporting crane that are also made of the huge crane. Have you seen the construction sites? Excuse me, 1 second, okay. Have you seen crane girders? Have you seen that?
Yes, sir.
They are supporting structures for a crane. Okay, so that are also made of what? that are also made of steel structures, like then the columns, beams in commercial buildings. Then plate girders. Have you seen plate girders? Plate girders are the structures supporting your bridges. Okay, you can see the railway steel bridges while you are traveling in train. You can see the railway bridges. Those are made of steel structures, and those are called as plate girders. Okay, and the transmission tower and the water tank, chimney, etc. These things are made of what? Majorly steel structure. So according to your concern is on what? Majorly your concern is residential building, but still you'll go for designing the stadiums, then designing airports. Those things also you architects usually design, right? At that time also you will encounter what? Using steel structures. Different steel structures will be, you will have to encounter, you have to suggest to the client that make it with steel structure like that, because it will give some aesthetical appearance also. If you mold it properly, if you have different sections, you can easily have larger spans, you can easily have large balconies, like cantilever. You can have a large span cantilever using steel sections. So you can easily suggest, like as an architect, you can easily suggest use of what? Steel structures if you want certain large span members, especially large span members, because you are not going to design any railway bridge, you are not going to design any crane girders, but you are going to design certain buildings, right? At that time, you can suggest to your client that you can use steel structures if you want a large span. Is it okay? Because the other thing, design of crane girders, then plate girders, etc., are the works given to the civil engineers. That most of the guys from architectural stream won't prefer to design those things, because there is no use of designing those things. But the other things like the cinema halls, then the transmission tower is also not there. The chimney, different, you can make it in different forms. That there sometimes the architects will also have a role in that. Okay, the other major things are the like huge span buildings. There comes the steel structures. Fine. Can I move to the next one?
Yes, sir.
Yeah. Yes. So the framed buildings, you might have seen this one, right? You might have seen this frame buildings, right? Have you seen this? The frame buildings, have you seen this one? So this is the time at the time of, this is at the time of construction. Okay. Excuse me. I'm sorry. This will stop. This is at the time of construction. You can see the frame building coming like this. Okay. The next one is industrial building. Have you seen this kind of construction? That is your factories, warehouse, etc. will be constructing with the help of this steel structure. That's what we have studied. See, you can see here your auditorium. The example is your auditorium. And then next one is truss bridges. Have you seen this kind of bridges anywhere? Have you seen this kind of bridges anywhere?
Yes.
Yeah, the railway bridges, most of the railway bridges you can see in this form. This is also entirely made of steel structure. Only the deck slab will be either concrete or it will be asphalt. Okay, but the entire supporting structure, here will be made of what? Will be made of steel. Only the deck slab will be made of what? Either concrete or it will be asphalt. Okay. And the suspension bridges also, you can see the suspension bridges also, the major thing will be what? Steel structure only. Then cable stayed bridges. Now comes the why you are preferring steel structure. That is the advantages of steel structure. That is why you are preferring the steel structure. That will be explained here. First one, can you tell me why you are preferring steel structure? Can someone tell me why you are preferring? Or you
Can take tensile force.
takes tensile force, then only tensile force.
Easy to construct, different sections are available.
Construct, yeah, sections,
Sir, it's
different
lightweight
section available.
construction.
Also,
Lightweight,
it like yeah.
lightweight.
Also, it consumes less space.
Very good. Less space.
Increase time.
Then less space. Then done.
We could span large area.
Yeah, that is what. Yeah, someone. Yeah, large area, span large area. Yeah, then done. Okay, fine. So we'll see one by one. Okay, high strength and stiffness. Someone has told, right? Yeah, it will be having high strength when compared to concrete. It will be having high strength as well as stiffness. What is stiffness? If I'm applying some load, the load required for unit deflection, that is called as stiffness, and that will be very much high when compared to what the other construction materials. When compared to other construction materials, this steel is having high strength as well as what high stiffness. Stiffness means what the load required for a unit deflection, 1 mm or 1 meter, whatever the deflection units are. The load required for a unit deflection, that will be very much what high. As a result, we prefer what the steel section. Now, being a ductile material, it does not fail suddenly. What do you mean by ductile material? What do you mean by ductile material? What do you mean by ductile material? That is, can someone tell what do you mean by ductile material?
It could be drawn into wires easily.
So suppose I'm having a chalk piece. I'm having a chalk piece. I'm having a steel hanger. I'm having a steel hanger like this. I'm having a steel hanger. Can you see this? What I'm drawing? I'm drawing a little bit down. That's why I'm asking. Can you see this? Can you see what I'm drawing?
Yes, sir.
I'm having a chalk. I'm having a chalk piece. I'm having a chalk piece, and I'm having a steel hanger. Now I'm applying the same force here. Which will fail first? Which will fail first? The chalk definitely fail, and the failure is a sudden failure, right? For the same load I am applying, the failure will be a sudden failure. There won't be any intimation, there won't be any warning. It will be sudden failure, and that is called as what? Your brittle failure. And the other one will take enough load and it will fail. It will first show some rotation at some point. There will be at some point it will show some rotation. Then only it will fail, right? You have experience, you have tried this at your home, or you have tried with some flexible materials, flexible materials, right? So that is the advantage of a ductile failure. That is, there will be enough alarming time. If the structure feels like it is going to fail, there will be enough time for the human beings or the living beings to escape from the structure. And what is the advantage of that? What is the advantage of that? What is the advantage of a brittle failure and a ductile failure? What is the advantage of that?
We could know, we could at least take some measures prior to the failure.
Yeah. Prior to the failure, either you can do the retrofitting, you can do the damage repair, or you can do anything. Like there will be enough, if there is an earthquake, something like that, you have enough time to escape from the building before the complete collapse of the structure take place. But in case of a brittle structure, in the case of a brittle material, what will happen? There will be a sudden failure. So try to avoid the brittle failure in structures, because it's all ultimately it is what the lives of a human being. It's the major thing we are constructing, or we are designing a building. The ultimate aim is what? It should not harm the living beings or animals or which is living inside that, right? So the ultimate thing is that, so that avoid constructing brittle failure material. Avoid constructing with brittle failure materials. So the advantage of steel is that it is a highly ductile material, and as a result, it is largely preferred for construction. Okay. Now, mass production. It is mass production means what? It is definitely the concrete is being casted in the site, right? So there are limitations because the amount of thing that can be casted at the site is limited. The workers are required, very much higher workers are required, laborers are required, many things are there, many limitations are there. Depends on this space available at this site. Different limitations are there in case of what? In case of concrete. But in case of steel, what is happening? It is actually a factory made, right? The sections are being made in the factory, which means it can be worked in 24/7. Then there will be a lot of machines. There will be enough space for storing the materials. There will be enough quality control. Many things will be there. So it is easy to have mass production, and as well as fast and easy erection and installation. Fast and easy erection and installation. That's why I told you an example for a BISMI electricals. I told you an example. As a single example, I told you is BISMI electricals. There are different steel structures. Why they have used this steel structure is that, suppose I want to open a commercial building. Okay, the revenue I'm getting from that is rupees 10 lakhs per day. Rupees 10 lakhs per day. So if I'm extending that for another 30 more days, the revenue that I'm going to obtain, or I'm going to get cut short by 3 crores, right? 30 days extension means what? If I'm opening the same shop 30 days before, I'm going to get around 3 crores of revenue from that. So the cost of construction with steel and concrete may be around 1 crore or 1.5 crore. Difference only will be there. So if I'm opening it with somewhat earlier, the revenue that I'm going to obtain is very much high. So the ease of construction and installation, many will prefer what? Steel structure. That is, the days of construction or the construction time can be drastically reduced, can be very much cut short or very much reduced using what? Steel structure. Have you understood? This is a very much advantage why the commercial buildings are being constructed with what? Steel structure. Is it okay? Is there any doubt for anyone up to here? Is there any doubt for anyone up to here? Children, please respond. Okay, is there any doubt?
Sir.
Yes. Can I continue?
Yes, sir.
Yes, sir.
Yes. The next is substantial elimination of delays due to weather. That is, if it is concrete structure, if there is a rain, there is anything like that, a major thing is rain or snowfall, then the construction cannot take place, right? During the time of raining and all, the construction cannot take place. The concrete will get immersed in water. Such time, the construction cannot take place. But if it is of steel structure and if this connection is being done with bolted connection, there is no problem in weather. There is no problem. Such delays due to weather can also be avoided in case of steel structure. Then the major thing is we can save a lot of money in formwork. There is no need of formwork required. Only you require scaffolding. There is no need of formwork required. A major part of your construction, 1 to 2% of your construction price will be from formwork, the design of formwork, the use of formwork. But in case of steel structure, the formwork is not required, which will save a lot of money, which will save a lot of labor, etc. Okay. Next, termite proof and rot proof. That is, there won't be any attack from termite or rot. So that will also is an advantage for using steel structure. Then there is a uniform quality. That is, I told you it is being factory made, which means there will be uniform quality throughout the section. There will be uniform quality, but you can't assure the same in case of what? Concrete structure, because it is being casted. It depends on the mindset of the labor. It depends on the physical behavior of the labor. It depends on the material being used at the site. It might be different material, so it depends on the material used at the site, etc. But in case of steel structure, it is being factory made. You can assure larger quality control, uniform quality throughout. Okay. Then lightness in economy. Someone has told the lightness in economy. Yeah, it is lightweight. It is lightweight. Light economy in transportation. That is, it is lightness. It will make easy in transportation and handling of the structure, because it is having smaller size. It is having lightweight. Smaller size also someone told, easy to construct. Yeah, someone told less space is required. Yeah, lightweight someone told. Yeah, that is. So it will be very much light. As a result, it will be easy for transportation and handling. Then the reuse of the structure. If it is a bolted structure, definitely after the use, if we are constructing a temporary structure, then the reuse of the structure will be very much easy in case of what? In case of steel structure, and easy for you to dismantle. The other one, concrete, you need to destruct it. There won't be any reusing of the structure. Then it is a recyclable material. If properly taken care of, it is a highly recyclable material, right? Isn't it? It is highly recyclable. You can shift from one place to another. It is reusable. There is no problem in that. Then better solution to cover large area and tall structures. Someone told this. Yeah, better to cover large span area. That is, it will be very much easy to cover large span and tall structure. That is what I told you in case of cinema halls, in case of auditorium, etc. It is very easy to cover large span. Definitely there will be some disadvantages also, but the major thing is the advantage. But in Kerala and in India, we see very much less amount of steel structures. Have you ever Have you ever thought of that? Recently, but there are many steel structures, but in previous around 5 to 10 years back, there are not much steel structures seen in Kerala or India. Have you ever thought of that? What is the reason for that? What is the reason for that? Can someone tell what is the reason for that?
Maybe the production was not that much earlier.
Production is there. There is Tata, there is Jindal, there is Visa. Many are producing this steel. No problem. Structural steel. But yeah, that is also one thing. After 2020, they started production. There is no use, then there is no need of production, right? There is no use, there is no need of production. That happened in case of structural. I am asking why there was no use. Leave it, no problem. So here comes the disadvantage of the steel structure. Disadvantage of the steel structure. It's open to corrosion. Have you seen the buildings, structures, the vehicles near your seashore? Have you ever seen that? Have you ever noticed what is happening there? The one,
Yeah.
it is prone to corrosion, right? There are, of course, rusting of the structure. So if not properly taken care of, not maintained properly, what will happen? The structure is very much prone to what? Structure is very much prone to corrosion. There occurs corrosion. The next one is high initial cost, and that's what I told you. In India, there is very much less, or there is less use of steel structures. And the initial cost is very high. It is very difficult for, I know as an architect, so you'll find it very difficult for the clients to make the clients understand that the initial cost, if you're going this way, the cost will be high, but it will be aesthetically very much good. You will save a lot of energy, like light energy, electricity, many things you can solve. But for convincing them, it is very difficult. But nowadays, it's very easy. But still, convincing them, it is very difficult. This happened long years back, a few years back in India. It was the initial cost that made many not to use steel structure. The initial cost will be very much high. As a result, when you are planning for a new construction or something like that, if the initial cost is very high, they will simply say that, okay, cost and but nowadays they are planning, they are saying that even though initial cost is very high, the revenue that they are going to get generated from that will be very much high when compared to the initial cost. So it's fine. They will straight away go with steel structure, and there are many advantages of the steel structure. Next, the buckling and high deformation due to small size of the members. I told you the members are very much small. As long as the thickness of the members decreases, what is going to happen? You have a structure like this. You have a column like this, and you have a similar column like this. You have a column made of concrete like this, and you have a similar column made of this. What is going to happen? This column has a tendency to fail by what? Crushing. There will be crushing, or there of course crushing. But here, at this crushing as well as what? There is a tendency for the column to what? There is a tendency for the column to what? Buckle. This is called as buckling of column. There is a tendency for the column to buckle. That is, thin members have a tendency, rather than crushing, they have a tendency to buckle. As I said, if you are using small members, there is a high chance for what? Buckling and high deformation. This is the deformation. This is the deformation delta. There is a high chance for what? Deformation to occur. That's why we will try to avoid what? Steel structures. Then.
Sir?
Yes, tell me.
Sir, despite this buckling problem, in Western countries, almost all the high-rise buildings use steel, right? So why is it that they don't have this problem? I mean, like,
they too have the problem. They use sections which are not prone to buckling. Understood. The design may be telling that they need to use around 300 mm width thickness of the section, or the total depth of the section may be 300, but they use what? Somewhat higher sections, such that they will check for buckling, and the section will be highly uneconomical. Understood. The required strength this section is only 300 mm, but due to this buckling factor, what will happen? The section required will be much higher than the required load carrying section.
Okay. So they are prepared to spend more money.
Yeah, definitely. You can understand. You'll understand soon once you are out of this college. You are dealing with a foreign client. They don't look for money. Mostly they won't look. Even you can see the buildings in Middle East and all. The actual cost of construction will be around, if the actual cost of construction without the aesthetic appearance will be much lesser. It will be, if you are using the, if you are going for the aesthetical beauty or appearance, it is going to cost you 1.5 to 1.7 times higher than the actual cost of construction. They won't look for money, especially the high-rise structures. They won't look for money, okay, because they want to get the attraction also. Such times they won't look for money, okay. So the limited fatigue resistance, that is what you mean by limited fatigue resistance. Due to repeated loading also, the resistance of the structure will decrease. It's not same as that of your concrete. Okay. Then low fire resistance and skilled labors required. Low fire resistance means it has got higher thermal expansion, thermal conductivity. It has got less resistance to fire. It will easily melt when compared to what concrete. And you require skilled labor. So these two things, and there is these two things, high initial cost and skilled labors, are the thing which makes or which limits the construction of steel structures in India. Understood? That is, we don't have much skilled labors working in steel structures, as well as we don't have much, we are very much neglect. We have a behavior behavior of negligence, that we don't spend much money in the construction. But nowadays it has just changed. A lot has just changed. So is it okay up to here, everyone? Is there any doubt up to here? Should I repeat any portion? Is it okay up to here?
Yes, sir.
Are we able
It's
to?
okay.
Yes, sir.
So can I continue with the next section?
Yes.
Okay, it's 11:17. Okay, we'll see. Next, the properties of steel. That is the properties of a section. As you can see in IS 800/2007, clause number 2.2.4. It's written there. The density is very much high. What is the density of the concrete used? Can you tell me what is the density of the concrete? Suppose it is 25 FCK. What will be the unit weight of the concrete? We have studied this last semester. So can you tell me the Young's modulus? Can you tell me the Young's modulus? It's 1000. We have studied. We have used this density of the concrete in order to determine the load carrying self weight of the load. It is 25 kilonewton per meter cube. Have you studied that for RCC?
Yes, sir.
Question of load, dead weight. Dead load of the structure we have used for 25 kilonewton per meter cube is the density or the unit weight of the concrete. But when compared to steel, what is it? It's around 3 times higher, right? It's 25, 50, 70, 8.5. It is almost 3 times higher, which means we can see as the density increases, the strength also what? Definitely the strength also what? It will increase, right? It's having high strength. For 1 meter cube, it is having 78.5 kilonewton, or it is having 7,850 kilogram. At the same time, this is having only what? It is having only 2,500 kilogram per meter cube. Understood? And the Young's modulus is also very much high. It is 2 into 10 raised to 5 Newton per. This is one typo mistake. Okay, type error. 2 into 10 raised to 5 Newton per mm square. The Young's modulus is also very much high. What is the Young's modulus for RC? If it is you are using M25 concrete, then what is the Young's modulus? Can you tell me what is the Young's modulus? You are using M25 concrete, then what is the Young's modulus? Can someone tell me what is the Young's modulus? Have you seen this 5,000 root FCK? You might have seen this 5,000 root FCK somewhere last semester. കണ്ടിട്ടുണ്ടോ? No one is replying. If you haven't seen, tell me you haven't seen. No, it's fine. This 5,000 root FCK means what? Is 5,000 root 25. Root 25, that is. Can you hear me? At least tell me that. Can you hear me?
Yes, sir.
5,000 root FCK means what? It is just what? It's just 5,000 into 5. That is 25,000 Newton per mm square. See the difference in Young's modulus. One is 2 lakhs, the other one is 25,000. That is, it's 8 times greater, right? Which means as the Young's modulus increases, the strength of the section also what? Will increase. This is just for M25. I'm just telling about M25. But still, difference will be very much high. If you are using M40, also difference will be very much high. So that is the advantage of what a steel structure. It is having high strength also. The Poisson's ratio. These are just the properties, physical properties you need to know. The Poisson's ratio is 0.3. The modulus of rigidity. These things. And the mechanical properties of the structure you can see in table number 1. Table number 1 is IS 800 2007. So if you are asked to write the properties of the steel, you can write these things. You can refer your IS code. You can write it, and you can go through that IS code. Okay, I will share you the IS code after this class. Straight after this class, you can see that. Is it okay? Any doubt up to here? Any doubt up to here?
No, sir.
Okay, fine. So we'll go to the next one. Steel sections. There is the different type of steel sections available. What is the time now? 11:20. Fine. Can I continue for another 5 minutes? Is it okay?
Yes, sir.
Yeah, fine. So the next is the steel sections. Okay. Can you please mute your mic? Someone's mic is on. Yeah, fine. Yes, steel sections. That is, steel section is what? Steel is a roll to required. Steel is rolled to a required shape during fabrication. That is, it will be in the molten state. We will be having one die with us. We'll pour this molten state of iron into this, and we will get the required shape of steel structure. Okay, that is the structural steel. According to the shape of the mold, we will get it in the factories. Next is the commonly available steel structure that I told you. The commonly available steel structure at the beginning, that is there. I section is available. Then the T section I have showed you. Channel section. Then angle section is there. Angle section I will present like this. Okay, angle section is there. Angle section is there. Then there are steel bars, tubes, plates, sheets, strips, etc. So these are the different type of steel sections available, or structural steel sections available. We'll come to each and every one by one. Okay, first we'll see I told you one book is there, IS 800. Along with that, there is one steel table I told you. You can see the properties of all these sections. You can see the properties, that is the density, the different dimensions, all these sections in this steel table. You can see that you can refer the steel table. You can see the different properties, sectional properties of the section available in the steel table. Okay, that is what I told you before. There is the T section, the angle section. Then this is the square tube section, hollow square section, HSS, hollow square section. Then this wide flange section. Wide flange means what? This is the flange, and this is web. Hope you know these things, right? So if the flange is very much large, then this section is called as wide flange beam section. And if it is very much the width of the flange is very much small, we'll call it as I section. This is called as I section. Then there is channel section. That is in the form of, it will be in the form of a channel. That is called as a channel section. Is it okay? Now first one, that is the I section. I section. There are different I sections available based on the there are different I section available based on the flange width, based on the thickness of the flange width, based on the thickness of the flange, based on the thickness of the web, based on the width of the web. There are different I section available. There is Indian Standard Junior Beam Section, ISJB, they are not as ISJB. Then light beam section, that is called as the property we will study later. That is Indian Standard Light Beam Section, Indian Standard Medium Beam Section, Indian Standard Wide Flange Section, and Indian Standard Heavy Beam. So these different sections have different use. Some will be used in design of columns. Some section will be used in design of beams, etc. So this design will be or the designer have the choice of selecting which kind of section to be used. But there are some guidelines that you should use. For columns, you should use this one. For beams, you should use this one. You will come to know that while in the coming modules. Okay. So if you have any doubt, you can ask me now, or if the doubts, if it is to be clear in the coming modules, I will tell you that. Otherwise, I will explain you. Have you got any doubt up to here? Is there any doubt?
No, sir.
No, sir.
Yes, Okay, fine. The next is role. Will come in detail what does this see. So this all will be represented ISL JB, that is junior beam, light beam, medium beam, wide flange beam section, heavy beam. All will be represented in this form. Is ISMB 500, or it's an example. Okay, ISMB 500 and point. It will be represented like ISMB 500 and 0.852 kilonewton per meter. This 500 represents the total depth of the section in mm. This 500 represents the total depth of the section in mm, and this 0.852 represents the weight of the section per unit length. That is, if I am running the section per unit length, unit length for 1 meter, then what is the weight of the section? That is 0.852 kilonewton per meter. So this is how the representation is given in your IS code. So if you see IS code, you could see ISMB 500 at 0.85, it is at, okay, at 0.852 kilonewton per meter, which means from here you will understand the section is Indian standard medium beam, having total depth 500 mm and weight 0.852 kilonewton per meter. Are you able to understand how to read the section details? That is, the first one will be defining the total depth, and the second one will be defining the weight per unit length of the section. Is it okay? Yes.
Yes, sir.
Now you can see the use of the section. Here it is used as C. We'll go for light section. Here it is used as C. Here it is used here. Then this being the I sections are used here. I section, you can see the I section which is being used all over here. See here the I section is used. Similarly, you can see the I section. See, it is used as a beam. The I section is used as a beam here. It is being used as a beam here. It is being used as a column here. You can see the different use of I section, and this section will be either it will be either ISMB, or it will be ISJB, or it can be ISHB. It depends on the design requirements. So it is being used for beams and columns majorly. See the I section used. You can see the small part of this. This is I section being used. See here, this is I section used. This is an I section used as a beam. This is an I section used as a column. This is an I section used as a column. This is the I section used as a plinth beam. This is a bracing actually. You can see that. And the wall will be constructed in between this portion. The wall will be constructed here if required. The wall will be constructed if required over here. And this will provide the frame structure. This will be acting as the frame structure. The whole thing will be acting as the frame structure. That is, this will be the load bearing entity of the structure, and the partition will be provided by some wall materials. So I think we can stop here, right, for today's class. It's 11:28. You have your next class at 11:30, something like that, right? So don't go. I just need to see you. Do you want this writings what I have written, or do you want just the PDF? I'll give you the PDF. Okay. I'll just give you the PDF. So stop sharing. So was it okay for you? Were you able to understand this mode of teaching?
Yes, sir.
Was it okay for everyone? 38. I think all are present, right? Almost everyone are present. So we will stop here. I'll give you the presentation up to today's where I taught up to today's class. There are some more portions remaining. I think we can finish the class as compared to your normal class. We won't take much time in your online classes. This is actually around 25% of your first module. What I taught today. So if you have any problem with if you have any doubt, you can ask in your this one. You can ask in your WhatsApp group. Okay, if you have any doubt. So we'll see. I think today's Tuesday, right? Next class is on. When is the next class?
Saturday.
Your next class timetable online. Yes.
Saturday.
You have your Saturday 9:30, but 8:30, right? But you have changed it to, right? You have changed it to 2 o'clock. It is okay for everyone, right? Considering yes, yes. ആരാ പറഞ്ഞത്?
Sir, Saturday we are having third period as activity period. Can you reschedule it to the third period?
Third period means what is the hour?
Activity hour.
No, I am asking what is the time?
It's
What
activity,
is the
sir.
time?
So it's like 10:30 something.
So time, sir, 10:30.
But at that time, some other teachers will come. Then I can't. This is actually the schedule is to be followed for the entire semester, right? So during the activity hours, we will be having some activities given by your advisor, something like that, right? So if you are doing that, or time being for this Saturday, we can do that. No problem. Okay, the Saturday will come at 10:30. If you have any activities given by your advisor, then we will come at 2 o'clock. Is it okay for everyone? But inform me prior to this, okay? At least one day before. If you have any activities assigned at that time. Is it okay, Abhishek?
Yes, sir.
Just inform me at least Friday night. I need to prepare accordingly because I also have
Okay.
Saturday is a whole day for me. So I am just coming for your class. Is it okay?
Okay.
So thank you everyone. See you.
Thank you, sir.
Bye.
Thank you, sir.
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 ഒക്കൂടെ ഒക്കൂടെ